Welcome to qnawire.
Our question says you are given a vector in the xy plane that has a magnitude of 90 units and a y component of minus 55 units. Then it says, A, what are the two possibilities for its x component? And B, assuming the x component is known to be positive, specify the vector, if you add it to the original one, would give a resultant vector that is 80 units long and points entirely in the minus x direction. Okay. So I wrote down here what we were given at the beginning of the problem. We were given that the magnitude of vector v is 90 units, and the vy component of that is minus 55 units. So then for part A, it wants us to determine the potential value for v sub y. Well, let's go ahead and use the fact that if we draw our vector v, we know that it has an x component and a y component. So this would be v sub x. This would be v sub y. It forms a right triangle, so we can use Pythagorean theorem to find the x component. So v squared, according to Pythagorean theorem, is equal to v sub x squared plus v sub y squared. Thus, v sub x is equal to the square root of v squared minus v sub y squared. Okay, well, let's go ahead and plug in our values for v and v sub y. So we know this now is going to be the square root of 90 squared minus, well, let's write our units. This is 90u squared minus 55 u squared. Let's finish something that out. Okay, and if you plug these into a calculator and you carry this out, you get plus or minus 71.2. We get plus or minus because we took the square root, and you don't know before the square root if it was a plus sign or a minus sign, since both would give you the same answer afterwards. Okay, so now we've determined the two possible values asked to determine for part A. Part B, then, I'm going to go ahead and get a new page here. Part B asks us to then determine what vector would need to be required for us to add it to our original vector. So we're going to call this new vector vector A, and give us a solution that has a value of a solution that's a vector with the value of minus 80 or 80 units in the minus x direction. So 80 units in the minus x direction is minus 80 units in the plus x direction. We can represent the x direction as it's this common notation of I hat. Hats always represent components of your axis. Okay, so we want something that gives us this value. Well, there's also an arbitrary 0 for the y direction, or its other common notation, j hat direction. Okay, so we need to determine a sub x and a sub y to give us these values, right? So we know what v sub x and v sub y are. We have 71.2 for v sub x, which is the I hat direction, minus 55 for v sub y, or j hat direction. And then we want to figure out a sub x that would need to be added to this, which would be in the I hat direction, and the a sub y, which would need to be added to this, which would be in the j hat direction, to give us our previous answer of minus 80 in the I hat direction. I'm not going to write the 0 because we know that that's there. Okay, so a sub y then is going to be the x component of the right-hand side of the equation minus v sub x, or 80 minus 80 minus v sub x, which is 71.2. And this is equal to minus 152. Okay, well, we're going to do the same thing for a sub y. A sub y, the right-hand side of the equation, is 0. So we're going to have 0 minus the left-hand side of the equation, which is minus 55. Minus a minus is plus 0 plus 55, which is equal to 55. Let's go ahead and include our units on these. These are all in values of units, right? Okay. Now, we are then able to determine, our vector A. Vector A is equal to the x component, which is minus 152 units in the I hat direction, plus the 55 units in the j hat direction. Okay, go ahead and box that in as our solution to part B.